This essay example, as well as thousands of others, is available in text format on our website for free and without registration. Simply Google IvyPanda Free Essays.
Introduction. Physics brings to light necessary knowledge on rotational motion. Moments of force have been applied to design rotating devices that help make work easier in almost every dimension. Moreover, the fact that these forces can be calculated makes them controllable and measurable. The rotation of objects is the fundamental theory behind most technologies emerging in the modern world. Almost every particle on Earth vibrates about its mean position. The theory of moments has led to the development of efficient movable parts along with their maintenance. This has boosted many industries, ranging from motor engine manufacturers to water pumps, among others. This paper will explore torque as a moment of force and its real-life applications. Torque. When an object rotates from its fulcrum, several observations are made: its speed, type of force, and such. This object requires some form of force to begin rotating about that point. This force, which enables an object to rotate, is called a torque. The point of rotation is known as the pivot or fulcrum. This rotation can be witnessed in machines such as seesaws, combustion engines, and water taps. Torque may be represented with an object rotating about an axis O. Let us call the force F and its distance from the axis, also known as a pivot, R. It is also imperative to note that R can be defined as the moment arm. Again, R is a vector, which is positive towards the object. Torque is therefore defined as the measure of this force F, which enables the object to rotate. Therefore, we can have the equation for torque as follows. Tau equals Rx, F equals Rf sin theta, where tau is torque. R is a vector and represents the moment arm. F is the force. Theta is the angular difference between the force F and axis O. In essence, as can be observed from the equation above, torque is simply the cross product of R and F. For example, torque equals Rxf. The SI unit of torque is Newton meter. Note that this unit is usually used to express joules. However, we should distinguish torque from energy as they are vector and scalar quantities, respectively. Since the calculation is a cross product, we can determine the direction of torque. This can be done by placing one's fingers towards the direction of R and then curling them towards the direction of F and observing the direction of the thumb. This method is known as the right-hand rule. There are situations wherein more than one force is applied to the exact moment arm. Each force causes torque, and there will be as many torques as the number of forces acting on the moment arm. Since torque is a vector, torques applied in different directions will cancel out if they are of the same magnitude or give a resultant if they are of varying magnitudes. The resultant of torques is known as the net torque. When the net torque is zero, then it is called rotational equilibrium. Real-life applications. Torque is applied in many areas of life, from industries to riding bicycles, opening doors, and many others. The following are some of the real-life applications of torque. Winches and seesaws. This is one of the most common and straightforward demonstrations of torque and its relationship with the moment arm, which is the point of balance and force. In a seesaw, two forces are applied on a long rod pivoted at about its center on both sides. Force is applied by the weight of those who sit on it. The resultant force that determines who is heavier depends on the distance from the pivot and weight. For instance, if two bodies sit on a seesaw 3 meters away from the pivot and weigh 40 and 50, respectively, we can have a resultant force of about 400 Newton on one side and 500 Newton on the other. This will give 1200 Newton meter on one side and 1500 Newton meter on the other. The 500 Newton weight will definitely go down while the other one is lifted. This can change. For example, if the 40 kilograms weight moves further to 4 meters from the pivot, as this will change its vertical force to 1600 Newton meter. In winches, the most critical consideration lies in its log nut. Even though the force may be constant, it is essential to note that the moment arm can be manipulated by varying distances from the pivot. This theory explains why doors have hinges that are placed as far as practicable from the pivot. Gyroscopes. Gyroscopes are other devices that apply torque. They contain flywheels usually mounted on top of the axle that is placed on a giant ring that is perpendicular to the moment arm. Once set to spin, they spin in 3 dimensions, which makes them very stable and provides them with the ability to resist changes that may try to upset their balance. In essence, this improves gyroscopic inertia, which suits it for navigational works. Gyroscope eases the understanding of torque when the right-hand rule is employed, since torque and angular momentum tend to be at odds when spinning. However, what fascinates is how these forces align to stabilize the gyroscope. For this to be achieved, conservation of angular momentum is required. Electric motor. Every electronic device that uses a motor as its driver makes use of torque in its applications. This includes household appliances as well as automobile engines. The energy produced in such engines is usually converted to torque so as to enable the car to move. The net torque converted depends on the state of that automobile. For instance, a starting car would require more torque than a moving one. The engine does this by controlling the number of revolutions, which in turn regulates the amount of torque conversions. Furthermore, torque is applied even in automatic engines where the torque converter transfers power to the gearbox from the flywheel. Every electric motor applies torque, as in vacuum cleaners and such. Torque is, therefore, essential for complex engines. Other applications of torque include tuning water taps, cycling, water pump, opening doors, hydraulic press, pulleys, screws, inclined planes, levers, and many others. Conclusion. Torque is an essential part of real-life applications. Its appliance ranges from one industry to another as well as in domestic life. It refers to the quantified force that just causes rotation about some axis. Its application varies from gyroscopes to motor engines, both manual and automatic. This makes it a central part of mechanical engineering as much as it is in physics. Did you like this torque supported by real-life applications sample? To get more works like this one, make sure to check out the free database of academic paper examples at ivpanda.com. You will find thousands of samples for all your study needs without even having to register.